Hello students, welcome to the second video of the chapter Complex Numbers. In this video, we will learn a bit about the modulus and conjugate of a complex number. Modulus, right? Modulus is basically, when we will go deeper into this chapter in higher classes, you will see that a complex number, like any number, when we plot it on a Cartesian plane, it has a coordinate like p 2, 3. Then we can plot it on a Cartesian plane by putting this dot and joining it to the origin. Similarly, every complex number has a presentation on a plane which is called Argand plane. Now, this topic was earlier in CBSE, but now it has been removed, and but few things are there which we need to learn for calculations also. Argand plane is a plane on which the complex numbers can be plotted, right? So that is called Argand plane. Regarding that, if a point is somewhere in a complex plane, then it has a measurement. Like if this is the origin and P is a complex number. So see, how do we write a complex number? X plus I, Y, right? Now let us say that P is a complex number, which is represented by Z, right? Z is X plus I, Y. Then this P has coordinates X, Y. And see, we have two things to represent it. On Argand plane, we require modulus as well as the measurement of this angle where it is placed. It is not there in your syllabus, so I'm just telling you the modulus is the measurement of this complex number on the Argand plane, right? Now that measurement is written as modulus of Z, and the value is calculated as square root of x square plus y square, right? So modulus of Z is square root of x square plus y square. This is a measurement of this complex number on the Argand plane, right? So we will not discuss those things which are not in syllabus. That is of no value. So if you have like Z is 3 minus 2 iota, then what is the modulus of Z? Modulus of Z is, this is 3 square added to negative 2 square. 3 square is 9, negative 2 square is 4. So modulus of Z is square root 30, right? This is how we find modulus of a complex number, right? Next we have conjugate. Conjugate of a complex number. Conjugate of a complex number. I hope you remember when we had learned in class 9, like if a number is like 3 plus root 2, when you have irrational numbers in the denominator, we are not supposed to write this as in the answer. In the standard form, you have to rationalize the denominator. Rationalize the denominator means you should not be having irrational numbers in the denominator. Similarly, if we get a number like 1 upon 3 plus 4 iota, if we have a complex number in the denominator, we have to convert it into a form in which iota is not present in the denominator, right? So iota is not in the denominator, so we need to take the conjugate. Here also we used to take conjugate. Remember this. What is a conjugate? It is the numbers remain same, but we change the sign of this part, which has to be removed. Here also, if we have 3 plus 4 iota, the conjugate is 3 minus 4 iota. If we multiply this denominator by this, the imaginary part from the denominator will be removed, right? That is the practical application. Let me now first tell you, if Z is represented by x plus iy, then the conjugate of Z is Z bar. which is x plus iy bar, right? And in that case, this is basically the symbol of conjugate. When we write it, it means we have to change the sign of the imaginary part, right? The conjugate of this is this. And vice versa. See, conjugate of x minus iy will be x plus iy. And conjugate of x plus iy will be x minus i. They are conjugate of each other, right? Now, what is the utility of conjugate? I have told you. Why do we use it? Let's say, I had told you in the previous video, we had done till multiplication. Now, let us come to division. That will involve this conjugate. Let's say z is 1 divided by 3 plus 4 iota. Now, you have to solve this. Solving something or writing a complex number in the standard form. I told you earlier, you always have to express a complex number in the standard form in which you should have some real part and some imaginary part. That's it. And iota, though it is here, but it is in the denominator. So we are not supposed to leave it here. We have to bring iota in the numerator. For that, we need to multiply this rational number with its conjugate. The conjugate of 3 plus 4 iota is 3 minus 4 iota, right? So now we solve it further. In the numerator, we have only 1 times. So this becomes 3 minus 4 iota. In denominator, what is the purpose of getting conjugate? Whether it was irrational numbers or whether it is a complex number. The taking of conjugate means you are using like x plus iy, x minus iy. This is a plus b, a minus b. We can use identity a square minus b square. So what is a here? X square, right? This is x square minus iota square y square. And we had learned that iota square value is minus 1. Minus 1 multiplied by this minus becomes this, right? So this is the purpose. We could have used a plus b whole square, a minus b whole square, but in that case, we get two ab terms, which will be having iota in it, again in the denominator. But we always use this a square minus b square because by squaring these two terms, the root part or the iota part gets eliminated, right? This is a square minus b square. So a square is 9 minus 16 iota square. This is 3 by 3 minus 4 iota. 9 I square is minus 1, so it becomes plus 16, right? This is 3 minus 4 iota by 25. So finally, we can express this in the standard form as 3 upon 25 minus 4 upon 25 iota. A plus IB, right? So that is why I didn't tell you this in the previous video. This is regarding the division of 2. Even if we have some other number in the numerator, this is division of two complex numbers. We need to multiply the rational number by the conjugate of the denominator. That just brings us a real number in the denominator, right? Okay, let me do one question which involves the conjugate and help you understand it more in terms of complex numbers. This is one of the best questions from NCERT. A plus IB is x plus I whole square upon 2x square plus 1. Prove that a square plus b square is equal to x square plus 1 whole square 2x square plus 1 square, right? So if this is given as a plus ib, let me check x plus I square, 2x square plus 1. Yes. Always remember one thing: you have so many questions of this kind in which a plus ib or x plus iy is given to you, and they're asking for the squares, sum of the squares. Remember this thing. Remember this thing. This is a pattern. When you multiply a complex number by its conjugate, see, when you multiply a number by its conjugate, you always get a square plus b square, x square plus y square, or whatever the numbers they have used in this standard form of the complex number. So what you have to do is, from here to here, this is given, and you need to reach to this point. That means if you have a plus ib, then you need to get a minus ib. Now there are so many rules in between which cannot be covered in this particular video. So let me give you 2 rules here. If z1 like z1 plus z2, this can be broken down into z1 plus z2. Right? Similarly, we can do this for subtraction also and multiplication division also. Z1 minus Z2. Then we have in multiplication, conjugates can be broken down into individual conjugates of the product. And finally, in division, Z1 by Z2, if we have to take the conjugate of a rational function, we can simply take the conjugate of the numerator as well as denominator. Right? So let me start from here. The ultimate aim is, I have got a plus ib in the question. And if I need to get this a square plus b square, I should first go for a plus ib. What does that mean? Taking conjugate on both sides. Or you can first do that. You can solve it a little bit because it is a whole square. A square plus b square plus 2ib. I'm breaking the numerator into, denominator is already a real number. I'm breaking down the numerator into real and imaginary parts. See now, x square. I square is what? Minus 1. This is the real part. And this is the imaginary part. And either you can take the denominator separately or once for the whole. Now this is the standard form. What I can do is, here you can write taking conjugate on both sides. Taking conjugate on both sides. What does that mean? If I am putting this bar sign over here and x square minus 1 plus 2xi, put a bar over here. I'm just eliminating one step because I'm short of space here. See, in the this rational function, if we put a bar on the numerator, that means we can take the conjugate on numerator as well as denominator separately. Right? Now, what is the conjugate of a plus ib? It is a minus ib. The conjugate of the numerator here on the RHS, this is the real part. So part remains same. The only thing is, only change the sign between the imaginary part. And look at the denominator here. It is already a real number. So we cannot take the conjugate of a real number. It has to be the same. There is no I part in the denominator. To treat this real number, conjugate of real number is the number itself. Now I need to erase this. Now simplify this. We have got, see, treat this as equation 1 and this as equation 2. Now multiply equation 1 by equation 2. That means multiply LHS by LHS and RHS by RHS. Here in equation 1 we have a plus ib. Here we have a minus ib. Now write the RHS of 2 equations. It is x square minus 1 plus 2xi And in this we have x square minus 1 minus 2xi. And the denominators get multiplied, so we can write 2x square plus 1 multiplied by 2x square plus 1. Now what is the value of this LHS? Now you should be able to write it orally, like a plus ib, learn this thing. X plus iy into x minus iy is x square plus y square. So a plus ib into a minus ib is a square plus b square. Now deal with these two. What is that? This is, check, this is a plus b. This whole is a plus this is b. This is a minus b. So a plus b minus b is a square minus b square, right? A square minus b square. Denominator is the square of this bracket. So we have got this LHS from here. We have got this denominator. We just need to simplify the numerator. A square plus b square. Be careful, like if you write here, this is a square plus b square minus 2ab. And if you take the square of this number, this is what? This is minus 4x square iota square. 2x square plus 1 whole square. Now try to understand this thing. This is iota square is nothing but plus. It just makes it plus 4. This is minus 2x square. This is plus 4x square. See, it was a square plus b square minus 2ab. Now if you take the difference of these two terms, this becomes x4 plus 1 plus 2x square, which can be written as x square plus 1 whole square. Right? This is a square plus b square plus 2ab. Again, see, the terms are same. The only thing is it was minus 2x square. Now by adding this, you have got plus 2x square. We can again make it a bracket. So a plus b whole square. And in denominator, we already had this. So you can check, you have got the same answer. A square plus b square is equal to this value. Hence, proved. You have around 7-8 questions of the same kind in NCERT and Adi Sharma. You can practice this. If you have any doubt, do let me know in the comments. And if you want to join my classes, please contact my profile through Apple Pro. Thank you.